So as a business, we're looking at how do we get accurate weather data across a whole area and large areas of farms and fields, which the localised data just can't be derived from national weather reports and things like that. And really, if we want to derive highly accurate pest and disease models, we really need highly localised data to allow us to do that. So what we want to do is develop these climate models and just assess how accurate they are going forward. What we then found is actually in the first few months of having this weather station, it proved useful just in its own right. So this weather station has a soil moisture probe which drops down to about 60 centimetres, and at every 10 centimetres it measures both temperature and moisture. We can know when we can touch this soil, when it would be right to do so, and also it can help us plan what crop we're going to put in. Are we going to be able to get that crop in the next few months? Will it be a winter crop, or would it be better to try and get things ready for a spring crop to arrive? In order for any pest or disease or growth model to be really accurate, the data that we use must be really localised, because as you can imagine, across this field and across this farm, the climatic conditions will change quite a lot. And therefore, we've been looking at trying to develop a climate modelling system that takes that into account. And what we found is something that will give us an accuracy to around a 1 kilometre square level. So that means that if you've got farms or fields that are far away from that farm, we don't have to rely on a weather station like this. We can rely on a virtual weather station, which we've validated using this actual weather station here to prove that we're in the high 80s towards 90% accuracy, to really then give us a really localised pest or disease pressure and risk analysis. And that will then allow us to build a lot more information and models and application timing work around that data that we've produced. The Efficient Agronomy project is the major part of the Predict and Justify project for this year on the Helix farm. And as the name suggests, it's all about trying to improve the efficiency of agronomy that we are doing on the fields. What it does is we're looking at how do we utilise technology alongside the experience and the knowledge of the agronomists to really help to give that agronomist more time to work with the farmer, work with the problems that are perhaps a little bit more involved, so things like rotation, planning his varieties, planning his markets, to give him more efficiency. We also want to improve the targeting of problems so that growers and agronomists don't have to scour whole fields to try and find issues or symptoms or signs of pest or disease attack. We want it to be very much more pinpointed than that. We want to be able to use these technologies and systems to say that's where the disease or pest is, that's the area that you need to focus on, and allow them then to use their time more wisely. We also really want to be able to give as much data as possible to that grower and agronomist. We want to make sure that they are making decisions based on all the information, rather than what they've managed to piece together from their field walking. The other side of it is time. It takes an awful lot of time to walk across all of the fields across a farm, identify the problems that they're seeing, and then report back. What we want to be able to do is get a good idea of those problems before we even arrive on the farm. We want to be able to say, actually, these are the things we need to come and look at, these are the things we need to address, and then spend time figuring out the best approach to doing that, rather than spending all of our time just diagnosing a problem. It's no doubt that over the last few years, technology has come on leaps and bounds, to the point where we're now able to capture huge amounts of data from a field, from different sensors, climate models, satellite data, NDVI imagery. The problem with that is all of that data requires more time in interpretation and reporting. So we need to be able to build that time in. And when we're deriving all of that data, we need an efficient way to use it all. We think that will probably be Omnia. We think we can use Omnia to start to take some of these different sensing data or information from the satellites and put those together in Omnia to really start to derive some management decisions for that field. The majority of new sensing and monitoring systems all give real-time information, which is really useful as an agronomist or as a grower, because we spend our time making decisions that are usually 3 to 4 days ahead of time, maybe a week ahead of time. What we would like to be able to do is actually make the decisions immediately, as soon as we find out that that pest or disease is present. So with these monitoring systems, actually they can tell us immediately when we're starting to see an issue, and we can decide whether we need to address that immediately or not. That will allow us a bit more time to discuss things around how that farm functions, around what other things we need to consider in that crop, and allow us to decide how quickly we need to adapt or not. The project will field test some of the new technology that we have access to now, but what's also exceedingly useful is that it might help to highlight some of the things that we don't have a current technological answer for. One of those that has already come up is something like slug monitoring. So because slugs are very small, very difficult to target, very difficult to see, and their symptoms are quite difficult to see until they've caused a lot of damage, certainly by anything like a satellite or any kind of imagery, that proves that we need something much more high resolution present in the field doing that monitoring for us. So one of the major selling points of this project is that it's going to help us to derive not only how we use what we have now, but what we need in the future. And we're going to work quite closely with Michael. We certainly don't foresee that agronomists won't enter fields anymore, farmers won't enter their fields anymore, but what we would really like to see is that the two work together. So the technology informs the farmer, that drives the decision, and then they can use that information they've got to create the best approach to resolving the problem.